Hey guys, this is section 4 on motion and energy, and we're going to talk specifically about energy this time. So work is done when an object is caused to move a certain distance, and energy is the ability to do that work. There's a couple different types of main energy sources. Kinetic energy, the energy an object has due to its motion, and that's going to depend on the mass and the speed. So if something's heavier or bigger, it's going to have more kinetic energy than something that's smaller, moving at the same rate. Or we can have two equal masses here, and the one that is going slower is going to have less kinetic energy than the one that's going faster. Then you also have gravitational potential energy. So if you can think of like two skiers, the same mass, the one that's higher at the top is going to have more energy, it's going to have more gravitational potential energy, and then when it's moving, it's going to have more kinetic energy. But the one that's slower is going to have less gravitational potential energy. It's just the stored energy for what is about to happen if it's going to move. If we have two skiers at the same height, but one that has more mass, then this one over here that has more mass is going to have more potential energy. And then there's elastic potential energy. And that's the energy stored in objects that can be stretched, like a bow or a rubber band, or things that can be compressed, like a sponge. And the mechanical energy, and you're not going to have to calculate this, but mechanical energy is just going to be the combination of kinetic and potential energy. A pendulum is a great way to explain all of this, because when it's pulled back over here, it has the greatest potential energy because it's right before it starts to go, or when you're holding it. But it's not moving, so it has no kinetic energy. Down here is the point where it's moving the fastest. That's when it has the greatest kinetic energy, but it has no potential energy. And then back over here, again, the greatest potential energy, but no kinetic energy because it stops for a second to move. Here's the diagram you should be familiar with. For the test, it's asking where does it have the least potential energy, the greatest kinetic, and so forth. This is the moment right before, or right after, sorry, it leaves your hand, if you were tossing this basketball up, and it comes down, and this is the moment right before it hits the ground. So try to answer these. Press pause and try to answer these, and then when you're ready, click the next slide. So you will see that the greatest potential energy is here, because this is when it's going to stop moving, just about before when it stops moving. The greatest kinetic energy, when it's moving the most, the least potential energy is down here, where it's moving the most because the gravity is working on it and stuff, is here. So the least potential is going to be where there's the greatest kinetic. And then the greatest potential energy is up here at C, because it's not going to move. Every object that goes up and then comes down has to stop for a split second, and that's what this represents. So right here, not only does it have the greatest potential energy, but it's not moving. It has 0 meters per second as far as the velocity goes. But is it accelerating here? It is, because it's changing direction. And then the law of conservation of energy means that no energy can be created or destroyed. It can only be transferred from one thing to another. That's it.